Use substitution to solve the system of equations. It's really important when you're using substitution, make sure you isolate one of the variables. Isolate one of the variables. Okay? And here they already have that done for us. Okay? So it says equation 2 is already solved for y. So we're going to substitute 2x minus 11 in for y in equation 1. So I see this y, I'm going to put this amount in for that y. So for the first equation, right here, they have negative 5 times x plus 2.5y equals negative 15. So they just wrote the original as it was. Then they have negative 5 plus 2.5 times your y amount. And what is that y amount? 2x minus 11. Notice the big set of parentheses right here. So the negative 5x, that is not in parentheses, doesn't get distributed with it all. And then we need to distribute this 2.5 times each term inside the parentheses. So 2.5 times 2x is going to be 5x for the first one, so just 5 in the bottom left rectangle, and 2.5 times negative 11 is going to be, I have no idea. 2.5 times 11, can someone do that? Negative 27.5. Okay, so this is just like the problem we just did. We have negative 5x and we have positive 5x. Those are like terms, and we would add them together, they would zero out. And so we are left with negative 27.5 is equal to negative 15. And you're like, what? That is false. And because that is false, what is my answer, my final answer? No solution. No solution. And so these two equations up here must go with what kind of lines again? Must be parallel lines. Okay? Any questions on that? Okay, let me see where I've headed. All right, so example 3 says apply the substitution method. This is a word problem. So it's really important to try to capture what's going on in this word problem, okay? Angela and Jasmine are paying off their credit card debt. Angela started out at $120 in debt. So this is Angela, $120 in debt, and plans to pay $1 every day. Jasmine is starting out at $150 in debt, and she plans to pay $2 every day. At what day will Angela and Jasmine be the same amount in debt? Okay. So we're talking about debt. All right. And each of them has different amounts. Let's do equation 1 for Angela. I'm just going to put Angela over here. We can get all of her information right here. So it says Angela is starting out at $120 in debt. Okay? We are talking about debt in general. So since she is starting out at that, let's leave a little space up at the front. So let's put $120. Okay, so we're talking about money that she owes, but we're not going to put it in a negative amount because we don't want to show what she still owes. We want to show the debt amount and how she's taking care of the debt. She plans to pay $1 every day. So what is that $1 every day going to do to that 120? Is that going to add to that debt, or is it going to take away from the debt? Take away. So how do I show taking away? Subtract. Okay, so let me put this in here. We are taking away from the debt for Angela. We're not adding to it. We are taking away from it. Now, she is going to pay $1 every day. $1 every day. Do we know how many days? No. So let's put, and sometimes, and I probably should have started this, but they didn't have it here. Let's say X is equal to the number of days that we're talking about. And we don't know what those days are. But she's going to pay down that debt $1 every day. So how might I represent $1 every day? 1x, because it's $1, and for how many days we don't know, but we know it's X number of days. Now this looks a lot like an equation, but I don't have the equal sign in there. She started at 120, pays $1 every day. That's taking away from the debt. What else could I put in there to make it an equation? Okay, where should I put it? In between anything here? To the left, to the right? Okay, we can put it to the right. So equals, and what is that going to be equal to? If X is the number of days, Y, shoot, why did I just say that? Y is going to be the amount that is still owed, right? Because if she starts at 120 and then she's paying down that debt, once we figure out what the X is, then that says, oh, she doesn't still owe 120, she owes 120 taking away some of that other debt. So the Y is going to be the amount she still owes. So we're going to set that equal to Y. Okay, and that is just for Angela. Does that make sense? EJ, does that make sense? You've got to try to understand this a little bit. All right, so let's talk about Jasmine. Talk to me about Jasmine. How is she starting out? How is she starting out, Sherlyn? Okay, how much is she in debt initially? Says she is starting out at how much? So 150, and she's not going to pay $1 down in debt. She's going to pay $2. And again, as she's paying that down, it's taking away from her total debt. So how might I represent that? Okay, so it's going to be minus 2x because she's doing $2 every day, and that's going to be equal to y. So as she's paying down this debt, y is the amount that she still owes overall. Now, I have two equations They are both in slope-intercept form. The slope here is negative 2x. That's your slope. Negative 2. Actually, negative 2. The slope over here is negative 1. Your y-intercept is 150. Y-intercept over here is 120. So I have y equals, and I have y equals. When you have two y equals, okay, you are going to set what they are both equal to each other. Because if y is equal to this whole amount, you are going to substitute that in place of that y. So essentially, what the both y's are equal to, you just set them equal to each other. So let's show 120 minus 1x is equal to 150 minus 2x. Does everybody see that? So you are just setting those equal to each other because now we have all x's. So I need to get my x terms all to the other side. Let's move the negative 2x because that'll get it positive on the other side. How do I move that negative 2x, Lennon? What do you think? Add 2x. And whatever you do on one side, you have to do on the other. So let's add 2x over here. The 2x's cancel on the right, and negative 1x plus 2x is 1x. You can bring the 120 out here. That is a positive 1x, okay? And that's equal to 150. So now I need to move the 120 over to the other side. Bear, how would I move that mathematically, that 120? Right, subtract. So subtract 120, subtract 120. Those cancel out. So 1x, or just x, is equal to 30. Now, it says, at what day will Angela and Jasmine have the same amount in debt? 30 days. So my answer here is going to be 30 days. We don't really have to solve for y, okay? But we could to figure out how much that debt would be when they were equal. So I'm just going to do it for funsies because I'm a math teacher like that. So I'm just going to substitute that x back in. 150 minus 2x is equal to y. So 150 minus 2 times 30 is equal to y. 150 minus 60 is equal to y. So y is equal to 90. So after 30 days of Angela paying down $1 and Jasmine paying down $2 a day, after 30 days, they will both owe only $90. Okay? Did you have to find this? No, you didn't have to find this. But you can if you go one more step. Questions on that example 3? Okay. So tomorrow we are going to go on to the next way to solve a system of equations. That's by elimination. Have you guys ever done that before? Elimination, linear combination? Maybe? Okay. And we'll spend 2 days on that. We have a fair amount of time. So if you have not gotten me homework number 1, I want you to be working on that. Or homework number 2. I want everybody working on these in that order. If you have both of those done, see if you can work on homework number 3. Homework number 3 is not due until Friday. Also, we do not have a new weekly Canvas activity. We're taking just a 1-week break from that. As far as I know, it's a 1-week break. But you still can do the weekly activity for September 2nd if you didn't do that. But it will close on Friday, this Friday at midnight. So if you have not done that, you have until midnight on Friday to get that done, okay? So I want everybody to be working on homework 1, homework 2, or homework 3, okay?